All right, welcome to Unit 1, Notes 3, which is probably one of our more difficult notes of the unit. The reason being is we're taking stuff that you spent a lot of time in middle school going over, and we're going to kind of cram it into one day of review. So let's start by learning the different forms of the equations. So the first form I want to talk about is slope-intercept form. That is the most commonly used form. The reason being is slope-intercept form is the form that we use to graph. Slope-intercept form is y equals mx plus b. Your m represents your slope, and your b represents your y-intercept. And we're going to look at how we can use those to graph here in a second. So slope can be looked at in many, many ways. The first way would be rise over run. Okay, that's typically what we say to ourselves when we're trying to graph things. We say rise over run. It could also be your change in y over your change in x. This change in y over change in x idea is represented really well by this y2 minus y1 over x2 minus x1. This right here is the equation we use if we're given 2 points and we need to calculate the slope between them. The y-intercept is the point where the graph crosses the y-axis. That's also the point where x is equal to 0. Okay, so remember the y-axis is the one that goes up and down. That's the vertical one. The biggest use of this, again, is to graph equations. So let's take a look at what that would look like. Right, let's take a look at this first graph here. Okay, so I want us to write the equation for this graph. All right, so in order to do that, we need two things. We need the slope and we need the y-intercept. So right here is my y-intercept. Here's my y-axis going down this way, and I'm crossing the y-axis at -2. So if I'm using this formula, y equals mx plus b, I'm just going to plug in what I know. The y and the x always stay in the equation. Okay, so I'm crossing a -2, so I could write plus a -2. You could also write this as x minus 2. Both of those are acceptable answers. So now I want to figure out how I'm going to get from point A to point B. You always want to work left to right. Up is positive, down is negative. Right is positive, left is negative. So let's go up. So we're going to go up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4. So I calculated my slope using rise over run, how many I went up, how many I went over. 6 over 4 is an okay answer, but we can do better. We want to reduce that fraction. 6 divided by 4 we can reduce to be 3 halves. Both of them are divisible by 2, and then you get 3 halves. So I'm going to plug that in for my m. So I'm going to have 3 over 2x in each version. You don't have to write both versions, but I will accept both. Both are perfectly acceptable answers. They're both correct. Let's take a look at this next one. So we're crossing the y-axis. Even though it's not labeled, we can still identify it. We're crossing the y-axis at a positive 1. So again, we're using that form y equals mx plus b. The b is 1. Okay, the y and the x stay in the equation. Now I want to calculate my slope. So I want to go from this point here to this point here. I want to work my way left to right. So I'm going to go down 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. So I went down 4 for this slope. I went down 4. Down is negative. And then I went right 6. So that's a positive 6. Well, I reduced the reciprocal of that fraction up there, so this is just going to be a -2/3 for the slope. So I'm going to plug that in where I had my m here, and I get -2/3 x plus 1. Okay, so down is negative, up is positive. If you didn't quite catch that, go back and watch this part again. Really think to yourself and see if you can do it. Okay? All right. So point slope form, this is one that a lot of students are really unfamiliar with, but it's actually a really nice formula. Okay, the formula is y minus y1 is equal to m times x minus x1, where x1, y1 is a point on the line. This is best used to write linear equations given a point and a slope, or 2 points. Okay, and we can get it into into slope-intercept form. Slope-intercept form is really easy to find. Okay, all you have to do is solve for y on any given form, and that gives you slope-intercept form. So I also write this a different way too. I also tell my students, look at it as a little puzzle. So that's kind of hard to see. Let's try red. So look at it this way. You have y, and then here, maybe you're going to put the opposite of the y coordinate is equal to, here you can plug in the slope. And then here you're going to do the opposite of the x coordinate. Okay, that's another way to look at it. Sometimes I say, look at this as a puzzle. And so you can plug that in, given a point and a slope. Hence the term point slope, a point and a slope. So let's take a look at how we can use this to get it into slope-intercept form so we can graph it. So first we have to put it in point-slope form. But before we even do that, we have to calculate the slope. So I have m is equal to 4 minus a negative 12. Here's my x1, here's my y1, here's my x2, here's my y2 when I'm laying out that point. So I did y2 minus y1. If I have minus minus, it becomes plus plus. And then I have x2 minus x1. Okay, so 4 plus 12 is going to give me 16. 8 minus 4 is 4, and that's going to give me 4. So the next thing I need to do is plug that into point-slope form. And here's the nice thing about point-slope form. If you are given 2 points, it doesn't matter which point you pick. Both points will work. They will both eventually give you the right answer. I usually just like to pick the first one because that's what my brain tends towards. So I'm going to set it up as kind of like that puzzle I was talking about. So in this blank right here, I'm going to put my slope, which is 4. And here, I'm going to put the opposite of my x coordinate. Well, my x coordinate is a positive 4, so I'm going to put minus 4. Note that that is a subtraction sign. And then my y is a negative 12, so I'm going to write a plus 12, and that is an addition sign. So make sure you're putting addition or subtraction in it, but you're not just writing y12. Now, in order to get it into slope-intercept form, I want you to go ahead and take this 4 and distribute it in. What we're doing now is we're solving this for y, then we can get it in slope-intercept form to graph. 4 times x is 4x. 4 times a negative 4 is negative 16. Next thing I want to do is subtract 12 from both sides. So I'm going to get y is equal to 4x minus 28. So that is my slope-intercept form. So all you have to do is solve it for y. What I'm going to do on this one is I'm going to get the slope set up for you, and then I want you to try and calculate it out. So we have x1, y1, x2, y2. So we have y2 minus y1 over x2 minus x1. So calculate the slope for me. Then I want you to use this kind of point slope idea. Plug in a point and plug in a slope. And then I want you to solve it for y and get what it would be in slope-intercept form. All right, next, let's talk about standard form of the equation. Standard form is best used for setting up word problems and equations. Okay, a, b, and c are all number constants. Okay, there's really no slope or intercept in this form. It's just a really good way to set up word problems. And a lot of times, if we want to graph it, we're actually going to solve it for y to get it in slope-intercept form. That's how we graph things in standard form. We solve it for y. And it's used to model situations. So basically with standard form, you have a times x plus b times y, and c is on the other side. So anything that is just a number, doesn't have an x or a y in it, needs to be brought over to the other side. That's standard form. So let's take a look at setting up some of these word problems. So for number 5, you have $10 to buy carrots and tomatoes for a salad. Tomatoes cost $2 per pound and carrots cost $1.25 per pound. Okay, so we're going to kind of ignore inequalities like we did yesterday. We're going to go back to equals. So let's pretend I went to the store and I want to spend exactly $10. Just as a side note, I'm going to let my x equal my carrots or my pounds of carrots, and y equals my tomatoes or my pounds of tomatoes. Okay, so let's look. Okay, so for every x pound of carrots that I buy, I'm spending $1.25. For every y pound of tomatoes I buy, I'm spending $2. And that's it. That's the standard form right there. If we wanted to graph this situation, we would solve for the y. But we don't have to graph it. All it's asking is a setup. All right, take a second to read through number 6. Go ahead and pause the video if you need to. I'm going to have you guys set this up. Here's what I will tell you. Your x is going to be equal to boxes of books. Your y is going to be equal to boxes of clothing. So see if you could set that situation up. Just take a second and try and set that situation up. Once you're done, go ahead and unpause the video and move on. All right, so we need to write an equation in standard form passing through the 2 points given. All right, so in order to do this, what we need to do is I need to first calculate the slope. So just like we were doing before. So y2 minus y1 over x2 minus x1. 7 minus 4 is 3. 5 minus 4 is 4. So I have 3/4. Next thing I want to do is plug this into that puzzle. So my slope goes here, and then I'm going to pick a point. I'm going to use 4, or 1, 4. So I'm going to have minus 4 here, minus 1 there. So to get it in standard form, I need my y's and my x on one side, and my things that are just a number on the other side. So I'm going to start distributing. 3/4 times x is 3/4 x minus 3/4. So now I need to get my x's and my y's on the same side. So I'm going to subtract 3/4 x from both sides. Then I get y minus 3/4 x minus 4 is equal to a negative 3/4. Last thing I need to do is I need to get my things that are just a number all on one side. So I need to add 4 to both sides. Keep in mind that 4 is the same as 16 over 4. So when I'm adding those fractions, I'm really taking 16 minus 3, which is going to give me 13/4. So kind of some icky fractions, but it's manageable. Okay, so go ahead and try number 8 on your own. Calculate that slope. So set it up once you have your x1, y1, x2, y2. See what your slope is. Plug it into point slope form. Get it in standard form. You want your y's and your x's all on the same side. Last but not least, we're going to do some matching. Okay, so all you have to do here is to put the graph with the equation that it matches. So this is multiple choice. Let's use that to our advantage. Okay, so I'll do one of them for you, and then I want you to do the last two. So if it's multiple choice, well, I see this +5 here. I say, okay, that's in slope-intercept. So that means that +5 is my intercept. So I know I'm crossing the y-axis at -5. So I'm going to look at the y-axis of each of these. Okay, remember the y-axis is that vertical line. Y-axis. Okay, well this one crosses the y-axis at -1. That's not what I want. This one at -5. That's not. Oh, this one crosses at +5. Let's just check the slope. So the slope is -6 over 1. If it's just a number, that's the same as over 1. So I'm going down 6 over 1. Let's just check it. 1, 2, 3, 4, 5, 6 over 1. All right, my slope is there. So C is that graph. So what I want you to do is pause the video and check out 10 and 11. See which ones match which graph. You only have 2 left to choose from. This concludes your video. Make sure you take your quiz once you're done.